Systematic listing. Assume you are rolling 2 dice. The first one is red and the second is green. Use a systematic listing to determine the number of ways you can roll a total less than 9 on the 2 dice. So here I'm going to use a systematic approach to list all the ways that I can roll 2 dice. Once I have all of those outcomes, I'm going to look at the outcomes and identify the number of ways that I can roll a total less than 9. So when we have 2 dice, the first one is red. And if you've seen a die, there are 6 sides to the die because it is a cube. So that means that there are 6 sides, and we label them as 1, 2, 3, 4, 5, and 6. Same with the green die. There are 6 sides, and those are also labeled 1, 2, 3, 4, 5, and 6. In order to take a systematic approach to this, we're going to create a diagram. And we're going to have rows and columns. So the columns are going to represent the green die. So I have 1, 2, 3, 4, 5, and 6 on my die. And then on the red die, this is going to represent my rows. I have 1, 2, 3, 4, 5, and 6 sides. So now I'm going to list the outcomes. So if I roll a 1 on the red die, I could also roll a 1 on the green die. So this outcome would be 1, 1, because I could get a 1 and a 1. If I roll a 1 on the red die, I could also roll a 2 on the green die. So my next outcome is 1, 2. I'm going to continue this pattern for rolling all the different sides or numbers on the green die. So again, the red is 1, but I could have a 3 for the green. Then I could have 1, 4, 1, 5, and 1, 6. Now I'm going to do the same thing with the number 2. So if I roll a 2 on the red die, I could possibly roll a 1 on the green die. So this could be 2, 1, and then 2, 2, 2, 3, 2, 4, 2, 5, and 2, 6. Again, if I roll a 3 on the red die, I could roll a 1 on the green die, so this would mean I'd have an outcome of 3, 1. I could roll a 2 on the green die, that would give me 3, 2 as an outcome, or 3, 3, 3, 4, 3, 5, or 3, 6. And I'm just going to continue this pattern. And again, this is a systematic approach to make sure that I list all of the outcomes. My last row, if I roll a red 6, I can have a green 1, a red 6 and a green 2, a red 6 and a green 3, a red 6 and a green 4, and then a red 6, a green 5, a red 6, and a green 6. So now I listed all of my outcomes for rolling 2 die. Now I want to determine the number of ways we can roll a total less than 9. So it can't equal 9, it has to be less than 9. So that means my total can be 1, 2, 3, 4, 5, 6, 7, or 8. So I'm going to look at all of my outcomes individually and add the numbers together. If the total is less than 9, then I'm going to count that in my answer. All right, so 1, 1. 1 plus 1 is 2. 2 is less than 9, so this outcome can be included. Next, 1 plus 2 is 3. 3 is less than 9, so we're going to include that. And I'm just circling the ones that are less than 9 to help me count them later on. 1 plus 3 is 4. That's less than 9. 1 plus 4 is 5. That's less than 9. 1 plus 5 is 6. That's less than 9. And then 1 plus 6 is 7, and that is also less than 9. Now 2 plus 1 is 3. So that's less than 9. 2 plus 2 is 4. 2 plus 3 is 5. 2 plus 4 is 6. 2 plus 5 is 7. And 2 plus 6 is 8. 3 plus 1 is 4. 3 plus 2 is 5. 3 plus 3 is 6. 3 plus 4 is 7. 3 plus 5 is 8. 3 plus 6 is 9. So I want totals less than 9, so I'm not going to circle that one because it equals 9. It's not less than 9, so I'm not going to include that. I'll go on to my next one. 4 plus 1 is 5. That's less than 9. 4 plus 2 is 6. 4 plus 3 is 7. 4 plus 4 is 8. 4 plus 5 is 9. And 4 plus 6 is 10. So I'm not going to include those. 5 plus 1 is 6. 5 plus 2 is 7. 5 plus 3 is 8. 5 plus 9. 5 plus 4 is 9. So I'm not going to include these. 6 plus 1 is 7. 6 plus 2 is 8. 6 plus 3 is 9. 6 plus 4 is 10. 6 plus 5 is 11. And 6 plus 6 is 12. So I'm not going to include any of those. So now I want to count the number of outcomes that I circled because those are all less than 9. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, and 26. So there are 26 ways that we can roll a total less than 9 on 2 dice. So my answer is 26. The answer is 26. In my math lab, select the answer box and type in 26. Check your answer. A designer has designed different tops, pants, and jackets to create outfits. How many different outfits can the models wear if she designed the following pieces? 8 tops, 3 pants, and 5 jackets. So here I'm going to start by drawing a tree diagram to see if we can find a pattern. Next, I'm going to use that pattern to find my final answer, and I'll show you what I'm talking about. So if I'm doing a tree diagram, my first set of branches is going to represent the 8 tops. So that means I'm going to draw 8 different branches. And each branch represents a top. So this can be top 1, top 2, top 3, top 4, top 5, top 6, top 7, and top 8. After I choose a top, I then can choose pants. So I have 3 different styles of pants. So from each top, I'm going to draw 3 branches to represent my options for pants. I have pants 1, pant 2, and pant 3. So notice I can draw 3 different branches for each top and label them pant 1, 2, and 3. Now I'm not going to complete this entire tree diagram because I want you to see if there's a pattern first. So after my pants, then I compare it with a jacket, and I have 5 different jackets. So that means from here, I'm going to have 5 different branches on each of the pants. Now notice that this is my last column, the jackets. So I'm going to have 5 branches here, 5 branches here, 5 branches here, and so on. So that means I'm going to multiply 5 by the number of pants that I wrote down, the number of branches for pants. So instead of writing out all of these branches, I know that there's a pattern. So I can just count the number of pant branches that I have, which is 24, and then multiply 24 by 5 because I know each set of pants is going to have 5 different options for jackets. Another easy way to do this is to simply multiply the number of tops times the number of pants times the number of jackets together. Each of those numbers represent the set of branches that I have to draw. So if I multiply them all together, I'll get the total number of different outfits that I can create. So instead of drawing all of those branches, I'm simply just going to multiply 8 times 3 times 5 together. So 8 times 3 times 5 is 120. So that means that I can make 120 different outfits with 8 tops, 3 pants, and 5 jackets. The answer is 120 different outfits. In my math lab, select the answer box and type in 120.